Okay, so this lesson is on curve sketching, and you'll see that there is a whole list of things that you need to be concerned with. I'll let you read those. I'm just going to go ahead and do an example, and then you'll see that I have all of these things completed when we're done. Okay? Oops, sorry. That's not what I wanted to do. This is what I wanted to do. So we're going to start with this example, y equals x squared minus 3x plus 4. However, what I want you to do is, I just do want to go into black. I want you to change this to a minus 4. I also made another mistake on the completed note, which I will correct here, and you'll see it when I get there. Okay. So we need to do restrictions on the domain. We need to figure out what the intercepts are. We have to do the max, min, and intervals of increasing and decreasing. So that's f prime at x. Inflection points in the intervals of concavity. That's f double prime at x. And then all of the end behavior. So, all right. And not necessarily in that order. Okay, so first thing we're going to do is intercepts. Alright, so I am going to take this function and I'm going to factor it. So this is going to factor into x minus 4x plus 1 over x minus 1 x plus 1. So we have a hole here. So we'll talk about that when we get to our discontinuities. Well, actually we can do them both at the same time. So we're going to do this, and we're going to look at discontinuities at the same time. Okay, so there is a hole at x equals -1 because of that. And so, and there is a, let's just do this, get this out of the way here. There is a vertical asymptote at x equals +1. All right, there is an x-intercept. That is where the numerator equals 0. So where y equals 0, which is where the numerator equals 0. So that is where x minus 4 equals 0. So that's at x equals 4. And then the y-intercept is where x equals 0, so that's 0 minus 4 over 0 minus 1, which equals +4. Alright, discontinuities, there's a hole, as I said, at x equals -1. There's a vertical asymptote at x equals +1. So we're going to do a plus-minus chart here, and we're going to say, okay, so there's an important points at -1, there is an important point at 1, and then there's an important thing going on at 4. This is a vertical asymptote, this is a hole, and this is our x-intercept. Oh, incidentally, at the hole, the y equals -1 minus 4 over -1 minus 1, which equals +5/2. Okay, so for the function y, I'll leave you to confirm this, but the function is going to be positive here, negative here, and positive here. Alright, so the plus-minus chart tells us what our behavior is at the vertical asymptote. So, since this is a positive, that means as x goes to 1 from the left, y is going to positive infinity. And since this one is negative, as x goes approaches 1 from the right, y is going to negative infinity. Okay, that's restrictions on the domain, that's our intercepts, and now what we're going to do is end behavior. So 3 is end behavior. Okay, so that's, is it a horizontal asymptote? Is it an oblique asymptote? What kind of asymptote is it? So because the degree of the numerator is equal to the degree of the denominator, you should have learned in advanced functions that you just need to look at the leading coefficients. So we have a leading coefficient of 1 here and a leading coefficient of 1 here. So that means that the horizontal asymptote is going to be at y equals 1 over 1, which equals 1. Okay, now we want to confirm what the end behavior is going to be. So as x goes to infinity, is the function going to be approaching 1 from above or below? And similarly, as x goes to negative infinity. So, in the past, you've probably been able to just substitute a number in and see how close it is to 1 and on what side of 1 it is. And that's generally okay, but what I really want you to do is do this using limits. This is calculus after all. So, now when the horizontal asymptote isn't at 1, in order to use limits, we want to know, is the function going to be positive or is the function going to be negative as x goes to infinity or negative infinity? But that doesn't make sense. If the horizontal asymptote is at 1, again, I'm just going to draw a little diagram here. So here's the x and y axis. Here's our horizontal asymptote at 1. If I'm approaching that axis from above, then the function is positive because it's above 1, and above 1 is a positive number. And if I'm approaching that from below, it's again positive because a number just below 1 is still a positive number. So it's not going to help us to determine its sign, positive or negative, because regardless of because it's always going to be positive. So that doesn't tell us if it's above or if it's below. So what we need to do is we need to take and we need to shift this asymptote down. What color? We need to shift this asymptote down to here, which means we're taking the whole function and we're shifting it down. So we're subtracting 1 from the function. So algebraically speaking, I'm going to erase that now. So algebraically speaking, we want to know what is the limit as x goes to infinity of our original function simplified, which is x minus 4 over x minus 1, brought down by 1. So that equals the limit as x goes to infinity of x minus 4 over x minus 1 minus x minus 1 over x minus 1, common denominator, is the limit as x goes to infinity of x minus 4 minus x plus 1 all over x minus 1, which equals the limit as x goes to infinity, x minus x is no x's, minus 4 plus 1 is minus 3 over x minus 1. So then what we get, as x is going to infinity, this will equal negative 3 over infinity minus 1. And infinity minus 1 is really just infinity, which means this is going to be a negative number, but it's a very, very small value. So it's approaching 0, but it's going to be negative. So that's 0 from below. And then when we take the same simplified expression as x approaches negative infinity, so negative 3 over x minus 1, that's going to equal negative 3 over negative infinity minus 1, which is negative infinity. That's a negative over a negative, which gives us a positive value, so that's approaching 0 but from above. So therefore, as x approaches infinity, y is approaching. Now let's move all this back up. If this was approaching 0 from below, then the function itself will be approaching 1 from below. And as x goes to negative infinity, since this was approaching 0 from above, then that means that y is going to approach 1 from above. Okay. Now let's take a look at the derivatives. We've got x minus 4 over x minus 1. Okay, so the function. So this is number 4. I've lost count. 1, 2, 3, 4. Yep. Okay, this is number 4. All right, and this is the critical values. All right, so y equals x minus 4 over x minus 1. So y prime equals the derivative of the top, which is 1, times the bottom, minus the derivative of the bottom, which is 1, times the top, all over the bottom squared. That's x minus x is no x's, minus 1 plus 4 is equal to 3 over x minus 1 squared. Okay, so y prime equals 0? Never. Because the numerator is 3, which is never going to be 0, so it's never going to happen. And y prime equals undefined, that would be at x equals 1. However, remember, we have a vertical asymptote there. So, doing a plus minus chart, that'll tell us what our, so we have no critical points. So therefore, no critical values or no critical points, which means we don't have any maximums, no minimums, no horizontal tangents, no vertical tangents. None of that is going on in this function. And so now we still have to do a plus minus chart to do the intervals of increasing and decreasing. However, the only important value here is 1, because that's where f prime was undefined. All right, so, or y prime. So if we put a number slightly smaller than 1, or any number smaller than 1 in this function here, that's going to be 3 over, that's a positive number, over another positive number, because squaring a number gives you a positive number, which means y prime is going to be positive. And similarly on the other side, it doesn't matter what value we put in here. The denominator is always going to be positive, the numerator is always going to be positive, so this is always going to be positive. So that means then that this function is increasing here and it's increasing here. But that doesn't mean that it's increasing from negative infinity to positive infinity because there is a vertical asymptote right here. So we say then that it's increasing on negative infinity to 1. We need a round bracket at 1 because the function is not defined there. And then from 1 to infinity. Okay, and the last thing to find is the inflection points. Oops, spelled that wrong. All right, inflection points. Okay, So y prime equals 3 over x minus 1 squared, which is the same as 3 times x minus 1 to the negative 2. So y double prime equals negative 6 times x minus 1 to the negative 3 times the derivative of what's inside, which equals 1. So that'll give us negative 6 over x minus 1 cubed. So y double prime equals 0. Again, never. The numerator is never going to equal 0. And y double prime is undefined at x equals 1, but again, there's a vertical asymptote there. Okay, so therefore, no inflection points. There's nothing going on here. There's no point to even consider. However, we can still do a plus minus chart to figure out the intervals of concavity. So, for y double prime, again, the only thing that is important here is 1. That's the only value that we calculated. On the left side of 1, the numerator here is negative. The denominator is also going to be negative. That means this is positive, which makes that concave up. I made a mistake here on the note that I posted on D2L. I said that was concave down. I was wrong. I said this was negative, but it's wrong. And then this is negative on this side. You got a negative over a positive in this function in the second derivative. So that's going to be concave down. Okay, so then that means that it is concave up on negative infinity to 1, concave down on 1 to infinity. All right, so let's just do some summarizing here before we do the function. Sorry, that's not very straight. So we have x, we have y, and we have, what's the significance? When x is equal to 4, y is equal to 0, that's an x-intercept. When x is equal to 0, y is equal to 4, and that's a y-intercept. When x is equal to negative 1, y is equal to 5/2, and that's a whole. When x is equal to 1, y is undefined, and that's a vertical asymptote. And when y is equal to 1, x is undefined, and that's a horizontal asymptote. All right, so we can start trying to draw this. So there's 4, that's my y-intercept. There's 4, that's my x-intercept. There's 1, there's my vertical asymptote. There's 1, there's my horizontal asymptote. Okay, so if you go back and take a look, as x is approaching 1 from the left, this is going up to positive infinity. And when x is approaching 1 from the right, this is going down to negative infinity. And as x goes to infinity, we're approaching 1 from below. And as x goes to to negative infinity, we're approaching 1 from above. And there you go. We're done. Oh, sorry, I forgot at negative 1, there's a hole right there. Okay, that's it. We're done. Thanks for watching.